So for problem 43, we're supposed to come up with a definition for this function. I don't remember how they word it. Write a definition for the function. So we've done this before. What we first want to kind of identify is how many pieces are there. And so I put 1 comma for each piece, so we can see there's 2 pieces. Then what we want to do is we want to identify the domain of the first piece. So the domain of the first piece would be, you could see all real numbers up until you get to 0, but including 0, right? So x has to be less than or equal to 0 for that piece of the piecewise function. And then the other piece of the other domain piece would be from 0 all the way to 2, but not including 0 and including 2. So we're going to include 2 with that less than or equal to. Okay. And now we just have to figure out the equations of these lines. Now, there's a very quick way to do it, and the more you kind of understand about slopes and y-intercepts, the easier this problem would be. So this line here, you can see has a slope. You can count down 1 and over 1, a slope of -1, and a y-intercept. If it keeps going, but still, this particular piece does connect with the origin, so the y-intercept is 0. And so how do we make, what equation do we come up with? Well, y equals mx plus b. We just substitute in the m, -1 times x plus b, which is 0, but that just simplifies to y equals -x. So you see how there's an equal sign here and an equal sign there, and a y there, and that's basically y. I mean, f of x, just function notation. But all we want to do is put that guy right here. Okay, so f of x is defined to be -x when x is less than or equal to 0. And then likewise, we could see that this slope is down 1 and over 1. Also the same slope, these 2 pieces are parallel, but this one has a y-intercept of, if it did go through all the way, it would hit 2, right? It would hit 2 on the y-axis. So this equation would be y equals -1x, or -x plus 2. And likewise, -x plus 2 is what's on the right side of the equal sign. Because we have 2 pieces, we have to split up f of x to the right of the equal sign into 2 different sections, just like we've done. And that's how you define this function that is graphed the way it is. Okay, and then finally, problem 47. We have a cost function that is a piecewise function modeling a real-life situation. A cell phone monthly cost, and kind of chuckling to myself, thinking, we don't have these kinds of piecewise functions anymore, for cell phones anyway, because you get anytime minutes. You just get a flat fee, and most plan we have anyway. I don't know if any plans nowadays where you're limited on minutes, or you have to pay extra if you go over a certain number of minutes. So anyway, this book was written, I don't know when, but technology is increasing rapidly here, the advancements. So even 10 years ago, this would have been normal. Anyway, this is a cell phone monthly cost. X represents the number of anytime minutes used. So in other words, as long as you use less than 450, less than or equal to 450 minutes, your flat fee, your cell phone monthly cost for this example would be $39.99, $39.99. All right. So therefore, cost of 200, if you use 200 anytime minutes, then your cost would be $39.99. I wonder if some of you were wondering if I was going to put that dollar sign. When we have a word problem, we always want to make sure we're answering our questions in context. All right? All of you 10 without the dollar signs out there. Anyway, the cost for, if you were to use 465 anytime minutes, well, clearly 465 is greater than 450, so now we have to use this second piece of this piecewise function, determining the cost, and we would write out, and you'd want to write it out. You don't want to just solve it without putting the numbers in. You would just take 465 multiply it by the 0.45, and this, it says, it explains it in the problem itself. I think the 45 is the cost per extra minute over 450. Anyway, so you've got 45 cents times the 465 anytime minutes minus, and then they have you subtract $162.51. I don't remember why it's that way, but you can read the problem if you want to know. 0.45 times 465, that is $209.25. And if we subtract $162.51, 62.51, I'm using a calculator, feel free to do that as well, 46.74, and then we would say therefore $46.74 would be the cost of if you had used 465 anytime minutes.